Okay, so this is about architecture of Claude code.
Mm-hmm.
Something they lead the source code, and I think from there these learnings come up in this book, right?
Mm-hmm.
Have you used Claude code?
Hmm?
Have you used Claude code so far?
Yeah, I use Codex, but both are almost same. Cloud
Both
Code
are
is but
right. Yeah. So we already know about like Claude code. No one need an introduction, and we know basically what things are there. Now we want
uh,
to deep inside it, go inside it. What are the components? And he
uh,
says like whole Cloud code is running on these six components. The components that are seen in this orange boxes.
uh.
So is a ripple loop.
Are you sharing some screen?
Oh yes. Okay, allow. I think I forgot this time. Can we stop and record again maybe?
No, no, that's okay. I think.
Okay, let's start.
Uh-huh.
So yeah, so this is the architecture of Cloud Code, and like it's essentially same concept as we use if you have used Cursor or Codex. The same principles, same underlying software, and
Okay.
it has six components, right?
Uh-huh.
So user is the user of the software, and
Mm-hmm.
then user interacts and input its questions. He's the
Mm-hmm.
developer, time user is the developer, right? And they interact with the ripple loop,
Mm-hmm.
right? So ripple is like circular loop that basically gives some interface, like it's like a CLI interface, right? Like if you see Bash is a ripple.
Uh-huh.
So they have something like Bash shell or
Uh-huh.
shell. Shell is ripple, or Python shell is also ripple, and
Mm-hmm.
here we input things. It's a terminal
Uh-huh.
interface, in short.
Okay.
And then these two things are like maybe in their design, this is they are not the core component. These are
Mm-hmm.
the six core components here. And I
Mm-hmm.
think, yeah, like if you understand all these six, I think this is all about it.
Memory, state layer, quick loop,
Yes.
hooks, tool system. Tool I know. Tool is like one
Tool,
particular thing. Tool is a particular thing that does one work.
yes. Tool is can be agentic, cannot be agentic, but tool is something that takes an input and do
Uh,
some action and give you back some results.
results. Okay. Okay. Correct.
Right? It might be like doing something that might not be reflected in the results, but yeah,
Uh-huh.
in general sense, it like it's some input and output. It can be simple print.
Maybe Google search. It may be API call. It may be anything, right?
Yes, it can be. Basically, it's a function. It's a
Fun-
Python function,
Okay.
right? That can do API calls as well. That can do
Mm,
whatever, and we can
mm.
discover tools with MCP server if you want to. But again, if you call it tool, you call it tool. So this is tool system,
Got it. Got it. Got it.
right? And they have 40 plus tools.
Okay. Okay.
Okay, then these are like query system, query loop. I think this is the biggest giant here.
Okay. Okay. That keep on running in the background.
Yes, query loop is like doing lot of things, and it's a async loop.
Okay.
As everything. So what does it do? It streams model output and execute tools and manage context. And
Mm-hmm.
this is the most interesting component here,
Mm-hmm.
right? Because if you see, there's a two-way communication with hooks, there's a two-way communication with tools, there is a two-way communication with stateful sets, so state layer, and then it definitely uses memory.
Memory also correct.
Yes. Then it also have two-way communication with task, and then like it takes the input from the ripple itself, right?
Task and tools are not same.
No, tasks are sub-agents. So these days a agent can spin up sub-agents.
Okay. Okay.
These sub-agents are called tasks. So
Oh,
I show you one loop actually, as I'm working on Claude, that will show you similar things. So if I go in Claude, this is cursor, and inside that, if you see, I'm using Claude. So
mm-hmm.
if you see, I will show you how this look like.
Mm-hmm.
In some traces, you will see when it is doing something, it will spin up a sub-agent. And maybe I'm just trying to show you some examples here. Uh, These are linear loops. There is no sub agent here. But when it is want to do something in parallel, it will spin up some sub agents, and it's very important to see how does it work actually. That will give you very visual context. Hmm.
Sub-agents. Okay. Okay.
Uh, okay. So these are tools, right? If you see this, these are using terminal tools and other things.
Uh-huh.
And
So
yeah,
this is mainly about harnessing, na? Like I think more you have harnessing better than
yes. So
because LLMs brain everyone has. Like,
yes.
LLMs are brain basically, and
So generally,
harnessing is right doing things locally without even going to.
harness can be overloaded. It can mean multiple things. But what happens is that one agent, Opus, can use multiple other agents to do the same thing in parallel.
Mm-hmm.
When it do that, it basically use this query, like it will basically create some task or sub agents. They
Uh-huh.
also called background worker,
Okay. Okay. Okay.
right?
Okay.
And they again have the same state machine. Now, this task itself will still use the query in loop, but the
Acha,
only
task itself is a complete again query loop and
yes,
REPL and everything.
yes, yes.
Got
And
it. Got it.
actually, sometimes cursor do mistakes, and this sub agents become a new thread or new agent. Like
Okay. Okay.
if you do closely not save it properly and other things. So by
Uh-huh.
mistake, do that. But actually, I can do one thing, right? Uh, create two sub agent and um, mm, call something maybe uh, and check uh, git status, maybe something like that. So what will it will do? It will start two different threads. These threads are exactly like what human will do. Look, if you see this sub agent starting up,
Oh, I add create two subagents and tag the status. What is the
yes,
command you are
whatever.
saying?
If you see this is the sub agent thread.
Okay. Okay.
This thread is not mine. So in this thread, who prompted it? The main agent is prompting
Yes.
this thread, right?
What was the main query? Create two subagents and check git status.
Something,
Okay. Whatever. Whatever. Okay. Okay.
whatever it is. Like I
And
also
all run
see,
parallelly and they coordinate with each other also.
yes, they run parallelly. Right now, by default, it use Composer too fast for
Okay.
subagents because subagent doesn't need to be that intelligent. But I can say make the subagent Opus, then it will do Opus,
Okay.
right? So this subagent, if you see, they're exactly like the main agent. Just like this is the main agent loop, this is
Uh,
subagent loop. It has everything, just like it started by a agent, not by a human. That's the only difference.
mm-hmm.
So that's what they're trying to say here. Sub agents also is like a ripple loop.
Grapple
It
loop, correct.
also,
They're taking input from query loop and basically they're
yes,
taking input from direct REPL and query loop also, and they have their own state layer.
but the two-way
Then
connection with the, yeah, they also have like everything. So
okay,
they also take a two-way communication from the query loop,
okay, okay.
right? So like query loop basically start agent and agent will return back and return the output to the query loop, right?
It's like I think Node.js engine only. Got
Yeah,
it.
yeah, exactly same concept, right? Yeah,
Correct,
yeah.
correct.
Now,
Okay,
what is memory? Memory is like all the information that we can put in the context is our memory.
okay, okay. That goes to the LLMs finally. Large
Yes,
language.
yes. To confuse it, they have something state layer that is mostly about app. So app has like the so as I didn't know that part, but Cloud Code is a React app. Even
Ah,
though it's
yeah.
a terminal, it's a completely web browser app, as you think of, right?
Hmm.
And it's a terminal app, but it is written in React, not in like some system tools. So it has a stateful management. So in React, there's something called Redux. It uses something similar.
Redux, I know. Redux, I know. I know Redux. Yeah.
Yeah. So yeah. So basically, it's the state of the front end, how things are there. I don't know why it's important, but it also get utilized and written during the query loop. It's mostly on the UI side functionality. It's not that important. I think main important is memory and hooks. Hooks are like lifecycle events. So they are
Mm-hmm.
pre-hooks and post-hooks for most things.
Yeah, these hooks are React hooks only, no?
No, they are
Okay.
lifecycle hooks.
Life
So
cycle.
lifecycle hooks are basically controlling some part of the life cycle, and they're very important. Like, say, if you want to do that every time before I call a tool, I want to do a pre-tool call hook, maybe
Mm-hmm.
pre-tool call hook that will do that if you have permission to call a tool or not.
Mm-hmm.
So as you develop more and more tools, every tool will have to go through the same life cycle. And if you have a permission engine created, all the
Mm-hmm.
tools that are created will follow the same permission engine.
Okay, okay,
Think of like their life cycle hooks. That's it,
okay.
right? Now, yes, a lot of things are React, and I don't know why. I have to understand what query.js is and why how much lines are there. I don't know, but basic concepts are there. Basic concepts are tasks. I think again it's a same concept as what user is, but it's started by agent, and
Mm.
tool system is the same tool system. Yes, and then this is the state. In the state, like again, it's like they're tracking a lot of information. It's like, think of like even as a database type of things, telemetry, model configuration, directory informations.
Cost tracking, UI
Yeah,
message.
Jusant is like a very popular solution if you know.
No, no, I don't know. What is just end?
Justant, it's a React state management solution.
Acha.
Yeah, it has like 57K stars.
Okay.
Yeah. So it's a very popular state machine, but like I have not used it practically. I just use like Redux type. Redux is like old and like again simple.
Uh-huh.
Okay. So this is how the state is working. And like it's maintaining the messages, input mode, tool approvals, progress integrator. This thing is, I think, written as a future proof that tomorrow, if they want to maybe merge it with VS Code and something, it's like already compatible because
Okay.
VS Code and all other things are also running the same React code.
Mm-hmm.
Basically, it's a React state store.
Mm-hmm. Okay, React store only. Okay, got it.
Yeah, it's a React store only. That's it.
ठीक है.
So I think like from my thing, I will not be worried about these things. Like it is just like how to like how buttons are there, how user what user is seeing, that type of things are there. But main
Mm.
things are task, tools,
Thank
query
you.
in the main part, right? And then we have hooks and memory,
Uh-huh.
right? In the memory, like basically this is how Claude remembers, right? Memory is like it has everything. It has
Mm-hmm.
everything from the parsing, from session start to relevant like conversations, current conversations, code based conversations, architecture decisions, debugging history. All these things are ultimately part of the context. So, like, memory is the context basically.
So memory and skills are similar or they are different?
Oh, skill is like not a memory. It is something like that agent can check and add to the memory if it has to do a particular task. So generally, skills are far more bigger and far like versatile than memory. So think of like skill like is a book.
Mm.
It's like a booklet that you are handling, like to how to change your tire if it is flat.
Okay.
And memory is like what to remember. Like you can remember a lot of things, but context will run out. But if you are carrying the books, like whatever you need the problem, you can revive that skill, learn the rules, and then take the operations. So it's like online memory, or like think of like notes.
Got it.
Yeah. So like it's a cheat sheet for you. So
Cheat.
uh,
Okay.
that's the text files. What are skills? They're text files.
Uh-huh. Or they even don't go to that cloud or like LLM also. They are basically instructions for that particular. No, they will go to LLM, but they are instructions for that problem only, but not for all the problems. They
Yes.
solve
So
small problems. Like you can say, check out gate or do this, like run this flow. So they are the skills that do the particular task. You can define your common skills, common task as a skill, right? That you do
yes.
on day-to-day basis.
So let's say you build a new server and like you have 10 different new tools,
Uh-huh.
right? And then you build a MCP server. So tools can be discovered, and agent can discover tool and run them.
Okay.
But either you document the tool too much, or agent can document it himself and create a new file, whatever
Okay.
the MCP server md or a skill file, and then you put it the skill file, and it basically have some information that whenever I use this server, I will have an introduction document that I will read, and I will know everything.
Mm-hmm.
even if tools like are not designed properly, even if you do like it basically like introspect the server, and like which is basically trying to like whatever he learns how to use about these things, right? It will
Mhm.
just note it down in a simple text file. So basically, like what is skill? It's just text file
Got it. Got it.
that it will append when it needs.
Mm-hmm. And
So
memory, how it avoids from like because sometimes memory become stale and it hallucinates. So how it keep on keeping the memory like up to date and relevant and
this
not
memory management is two stages.
okay.
Most people like that big memory, small memory. For small memory that we call it that we want to fit in the conversations, we do some part like agentic compaction.
Mm-hmm.
So in a cursor, if you see this particular bar, if
Mm-hmm.
you say how much context is being used. So right now, if you see 60% of my context is full and 40% of my context is remaining.
Oh, what it means? 60% full means?
So whatever context is like, so if it is like 10K, or right now what 200K context window is there, right?
Mm-hmm.
And out of 200K context window, I have used 120K context window. So I have used 60% of my context.
And this will keep on increasing throughout the day, or it is a monthly limit, or it is like that particular
No,
thing.
no, it's a context window. It's like it's not a cost thing. It's a model thing. So
Okay.
model can only see 1 to 200K tokens, right?
Uh-huh.
So right now model is seeing 120K tokens. Now, if as I add more and more conversations, the
Mm-hmm.
context will keep filling, right? It will fill after like after 200K, it will be done. At the
Mm-hmm.
time, it will do a compaction. So
Okay,
it,
okay.
it will put the all the summary and summarize the summary. It will take all the conversations and put a summary and replace with the summary. At the time, it will lose a lot of information. But
Got it.
since it will do it, so you will see the compaction. Like if you see, you will never be at 100%.
Got it. Got it.
You go to 90%, there will be compaction, and you will go back to like 10 to 15%.
Oh, okay, okay. Got it.
Right? So right now, if you see here, I am at 83%, 81%.
Acha.
As I put more and more conversation, when it's
हाँ.
about to fill the context window, it
Mm-hmm.
will compact it and like clean up my window. But in that cleanup, I will lose a lot of information. More agentic model will try to lose the non-relevant information. So it will try his best to keep the right most important tokens. But still, I can still lose things, right?
Okay.
But there is a limit of how many times you can do compaction. At some point, it will not allow further compaction. It will say just remove this thread and start a new agent or start a new conversation.
Okay.
Because
Got.
like after compaction and you're losing things, right? After some times, like you will lose everything. So it will
Got it.
like allow you like for 10 to 15 compaction, and after that says, okay, don't do any more
Got
compaction,
it.
just
Got it.
delete that.
So it is like state machine is keeping take care of everything. Got it. Got it.
Yeah. So this is like my short-term memory, or this is
हाँ.
like a context memory that we manage. This is most important memory. Think of it like RAM. Then
Mm-hmm.
second memory is disk, right? And in the context of disk, like we have something called RAG. Cloud code doesn't have it, right?
Reg
Cloud,
na reg usually we do for other things. Got it.
no, cursor has a RAG. So if you
Okay.
see cursor, they build a RAG here. Like you can go and like basically open the RAG even.
Okay. Okay.
Cursor RAG, they call it index, and
Okay.
you see they basically index every source code for you, so that they can quickly find what things to manage, what things to there. Somewhere in the settings is there, and yeah, indexing and docs, right?
Mm-hmm.
This is your code bit indexing. This code bit indexing is nothing other than RAG.
Elastic search only kind of.
Yeah, Elasticsearch also is a RAG. It's like it basically take all your code and convert it into tokens.
Correct, correct. So that querying is faster and
Yeah, you
before
can
sending to LLM, it will do internal reg query and then will only send to that end
yes,
user.
yes, and there are some rules that only folder that have less than 250K files will be indexed, right? And right now my index is not up to date, so let me reindex it. So it's like a very big memory. It's like a understanding of whole code base. Code base is big. It cannot be fit into 200K context window, right?
Correct, correct.
Right. Then we discuss about hooks, right? Everything we can define lifecycle hook. Pre-tools and post-tool. Pre-tool is the most important example because we always do some permission check before a tool call.
Mm-hmm.
So this is the golden path. How does it happens when you enter some prompt in a cursor, right? So I will start. So first thing happens is that from the user or REPL, user message goes to the query loop and it looks like this, right? Add error handling to the login function and it start thinking. So what happens here? User message, REPL captures input and wraps it as a user message.
Mm-hmm.
So in agentic, there are different type of messages. One is called user message. Second is called agent message.
System message, system prompt.
Yes, user prompt, system prompt, tool prompt, or whatever. Like there are different type of messages.
Uh-huh.
So this is user message. So basically, whatever you put, it becomes a user message and feeds to the query loop,
Okay.
right? And it starts like it give you some UI hint that it's thinking. Step two. Now what happens? We do a token count check, and we see check the context window. Auto compact if conversation exceeds the budget. So that's what I already show you, right?
Mm-hmm.
If you're going over the context window, we will just compact the context window.
Mm-hmm.
Also, it can check some like see how many tokens you have used, and if you don't have token, you can send a message.
Mm-hmm.
Right? Because like you're build based on tokens. So if you're out of tokens, anyone has any questions so far? I see some people like someone else
Yeah.
has joined.
Yeah. So Girish, you have any question? Like there is one more Girish.
Alright. No, no. I'll ask it last if I will have any.
Okay. Okay, sure. So this is the query loop. After that, next step will be uh, going to the model, right? So token count check is done, and now actually we are streaming the tokens to the agent. So generally, when you press enter, you send a bulk message
Mm-hmm.
to the agent, and most conversations are that one side it's a bulk message, and second side it's a stream.
Mm-hmm.
But actually, transformer doesn't work like that. Transformers take some token by token input and they give token by token output. So even when you press enter, right, it's a way to send like some information. Transformer, you can still append to the things. Most framework don't allow it. You see, like if you chat GPT, when you press enter, can you add more information after that in the same loop?
No, no, there is no way, na. Like it will wait for till the first one completes.
Yeah, but where is the limitation? The limitation is not in the LLM.
Okay.
Limitation is just interface. We want to interface to not do it. So like we don't want to interface to be complicated. That's why we never add more information, because like what do you mean by send all the like agent doesn't see the whole message.
Mm-hmm.
If you send like 100 tokens, it will see first token and then second token and third token
Mm-hmm.
and fourth token. At the time you can add more tokens if you want to.
Mm-hmm.
Right? Why I'm telling you this thing? Because this is how LLM works. And we use it, but we don't show it to user
Yeah,
in a
but
way.
we take one. Say if I am planning my trip to Jaipur. Say I write a query that I am planning visit this week, this month. Tell me all the places. So say if I read one paragraph, so it will do. It will send in one go only, na, to the LLM. Like all the query will go in the one loop only, right? One
Yes,
way.
it will send in one go to the LLM, but LLM cannot take everything in one go. LLM read token by token,
Okay, okay,
and
okay,
it
got it.
takes time to read token by token, right? So
Okay.
by the, and like why it can basically like it start generating token by token, and like you can still add more and more tokens if it is not done. It's not generate after it read everything. It basically start generating based on the information immediately. Okay, so we just use it for prefill, but after prefill we start generating. I will tell you why I'm talking about this thing, because there's some architecture decisions that depend on it. So once we do call tool, right, we call a model, and we like it will stream the request to the right. Think about stream, right? It will stream request to the what is the request? It's a system prompt plus memory plus conversation history so far. It will send to the API, Cloud
Oh,
API, the
okay.
stream.
System prompt is not always fixed. That is again part of memory only. That is fixed. System prompt is what, like that I am asking as a query that write
Yeah,
code.
I don't like you can say everything is memory. System prompt and conversation history is the memory
Okay.
opinion. But yeah, but again, right? Yeah, if you want to include them and exclude them, there's so many ways. Now, at this point, the model receive the message. It
Uh-huh.
will start thinking like now GPUs are involved, and it will generate some new tokens, right?
Okay.
Now, new tokens will stream back. They use SSE. You know SSE?
SSE. Acha, acha.
SSE is a HTTP extension that streams one token at a time. Like if you see right now, like if you do inspect window, right?
Uh-huh.
Oh, maybe actually open ChatGPT and you can see it. So if you open ChatGPT, right,
Mm-hmm.
and you do inspect in your network tab, you can see that there are different type of connections here, right? And when you press enter, it will like give you one token at a time, right? So how does it work? It works through,
This is streaming. This is streaming. I know this.
yeah, SSE is the streaming extension something.
Correct. That we use like because someone is querying and then it is coming as a stream that we are using in our flow also we are using
Yes.
so that
Uh,
it end user thinks okay something is coming as a like so like he has patience na otherwise correct got it.
yes. But do you know like how does streaming work? It's like a token by token. And
Uh-huh.
I have to find the right API, but you can see the SSE extensions. Just like WebSocket is a different protocol, SSE is a different protocol.
Mhm.
Okay. So this is streams back to these things. Now, here in the query loop, in the stream, we have to we have to find the text blocks and the tool blocks. So model give you some tool blocks. So model cannot call agent, it just generates some tokens, right? Now in a generate, it can say, okay, use this terminal tool and in the terminal print this thing, right? Now what you
Mhm.
have to do? You have to make the tool call. You have to call the terminal with the input. So agent can only say this, call this tool with this argument. Now you have to identify the tool calls. You have to format it correctly so that the user can see, okay, there's a tool being called. And then what will happen? You will call the tool. You detect the tool blocks, call the tools with a streaming tool executor. And
Mhm.
streaming tool executor, what will it do? Intercept the tool use blocks and midstream before the response is even complete. So even right now, agent is generating tokens, but as soon as it generates a token call, a tool call, and it is generating further tokens, we start this query loop will like in the mid thing it will start immediately the tool call with a streaming tool executor. Now
Okay.
we'll go to tool system. Tool system will be executing the tool, right?
Okay.
And again, think about that. Like if it is a big response, agent model might be still generating new tokens, and it will finish this tool call. And what will happen here? It will get some results from the tools, right?
Mhm.
Once it gets the result from the tools, what it will do? It will put the result in the context. There's
Mhm.
no new enter here. Do you understand what I'm saying?
नहीं, ये वाला this I last part
Yeah.
This is
So
now we are talking about, say, LLM is getting token by token and how it is responding to the end user that we are talking about, right? So how
yeah,
it works, you are telling.
yes, and I will show you the example here. So do you
Hmm.
remember, right?
Hmm?
Do you remember when we say create to subagent and do status check, right?
Correct, 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 correct.
So this particular thing, right? This particular conversation, it happened as a tool.
Hmm, 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 hmm.
This agent is a tool that basically takes some input, this argument
Hmm,
here,
hmm,
and give me this whole stream. Do you know
hmm,
this stream is added to the same context? There's no new enter here.
hmm, hmm,
Means like there are two type of enter, right? From my side, there was an enter here, definitely. But
hmm,
here, the agent is still generating tokens, but sub agent is also generating tokens, and sub agents tokens are putting into the agent context.
hmm,
But agent is not done. Now this is tool call.
hmm, hmm,
The tool call, it says run command cd and git status, right?
hmm,
Then it's use a terminal tool, and it give you this input, and then terminal tool will give you this output.
hmm, hmm.
This information is added to the same context again, but agent is not done. Agent is still generating more tokens.
Generating tokens means I did not read. Generating tokens means
Like it's printing. Like
printing. Okay, okay. Output token. You are talking about output tokens.
generating means outputting token. Yes,
Got it, got it, got it.
Like transformer generates a token, right? This is a new thing, right? Generation is a new thing. It's expensive.
Ah, correct,
So
correct, correct.
right, it is still generating, and now it sees that these things are in the context already. Now,
Hmm,
based on these things, it will change this output here. So this particular, it's already see the subagent one input now, and subagent two and tools input. It will say, okay, subagent says something, subagent two says something, and this is what this is final thing. So you understand? This is the query loop.
okay, okay,
So
okay.
it's continuously inputting the information from the tools into the context. That's what I'm trying to say here. That
Got
here, even though first tool is done, right? The agent is not stopped. Query loop is still working and putting the information into the model context. And then, based on the first tools, it might select a different tool now. Like
it.
you can say, okay, first tool output is there, and then based on that output, it might select like different tool based on the first tool's output, right?
Correct, correct,
Right, because the information is appended to the context.
correct.
Based on that context, model is outputting new token based on the previous tokens, right? The previous tokens changes and models output will keep changing. For example, if this output have been like right now it says 11 check passed, it output would have been something different, right?
Mm,
If this output would have been something different, the it might have done maybe more things here instead of like closing the argument.
mhm.
You understand? So
Yeah.
if you see here, like this was your input, right? And this is the tool call, and it's doing some editing. It's update the 42 lines. Why it updated the 42 lines? Because uh, it decided that I should use a uh, vi tool, like vi like tool that would edit the file.
Okay.
They have more graphical tool that don't edit the file but put some information for user to accept and reject, because user is also a tool. But let's say they want to just edit the file, so they have a file editor tool, and it will say go to the file editor tool and on this line edit this thing, right? And
Okay.
then executor will make that happen.
Okay.
Next step, tool result message, result map to the context block, right?
Mhm.
Burst it to per token size cap and append it to the history.
Okay.
Next step, stop check, more tool call pending, continue loop, or no more calls, right? So if you see, like, do you want, like, is agent is asking to do more tool calls?
Okay. Okay.
If it is calling more tool calls, what will happen? It will again go back to this streaming tool executors, and then tool system will response back, and we will put into the context again. But let's say there's no more, agent is like done. It says, okay, I don't need to call any more tools. What we'll do? We will, no more tool calls. We will generate the final response. So here it says no more tool call detected, loop continues. Oh, more tool call detected, loop continues. So right now loop will continue. Let's go further. So now it is yielding the final message here. So what happened here? So maybe go back. Oh, there's no going back here. So remaining tool calls and then remaining tool call messages come back in the same context. Then we checked again, and then this time we closed, and then we yielded the final message. And then final message is displayed to the user. And this final message is done adding retry catch blocks with specific error types for auth failure, any response from agent.
Mm-hmm.
It's important. Like I can like start again. User message, user
Okay.
message, token count check, then streaming it to model.
Mm-hmm.
Model will stream back tokens. From the token, we will detect the tool calls. I think we detect here. I think it's misaligned here. It's a query loop task. Then we start concurrent tool calls. Then we will finish the tool calls even when model is not done.
Mm-hmm.
Step further, we execute remaining tools if there are remaining tools here. Step next, tool result message are appended to the context or history. Next step, we will see if there are more tool calls. Next step, yes, there are more tool calls. Updated the context, right? Context is updated and more information is there.
Mm-hmm. So this
Now
context are updated.
for
That
the model now, yeah, model now will have the full context. So
okay.
model understand this tool has been called and this was the result at this time.
So now
Next
this
step,
everything is happening at LLM level. All these things, na, that you are talking about, or it is at this.
everything is handling at the in this query loop.
Oh, it is not LLM. Like it is that query loop is handling, right?
Query loop is appending the context and then context is being sent to LLM. Yes.
Okay, okay, okay.
LLM will see everything in a particular manner because of this query loop. Query
But
loop
now
finds
my okay, I got it. So basically, this Claude or anything, they don't send all the tokens together. They send one by one, and because LLMs also process one by one only, like as a human brain, you can't dump everything, right? They take token by token. So
mm,
LLM is keep on getting the tokens. They are streaming and again getting tokens by agent and then doing the work, right?
the agent. Yes, agent generates token by token. There's something called prefill where you can give a back big message and it will read it through
Okay,
before it
okay.
starts generating the token. But once you start generating the token, this token get appended to the like to the input anyway to continue generating the new token. At
Mhm.
the time, it you can still add more and more tokens in the same conversation.
Okay, okay. Got it. Got it.
Okay, so this is the main flow here, right? Three things to notice here: the query loop is a generator; it's not a callback chain. The ripple pulls the message from it via for wait. I think it's language
Yeah,
TypeScript specific.
Node.js await. Yeah, yeah. It's like I think.
So it says it means back pressure is natural, right? It might be model generating too much, and front UI cannot keep up. It says in that says it will say it will try it will like it is made pressure available is that if token are generated too fast and UI is not able to display them, then we will ask model not to stop because again, if you cannot see it, why we want to burn money?
Mhm.
So it's a deliberate choice over event emitters and observable streams. Why we want to just do a ripple loop here? Because we want to be more pressure aware. And if UI is not able to keep up, we want to generator to stop and stop burning the tokens.
Hey, sorry to interrupt. I just saw a message from Sahil. He's waiting in the waiting area.
Okay, okay, just a minute.
Oh, sure.
No, I didn't. I can't see him. Can
I
he
can.
join?
Oh, I saw messages just now.
Okay, okay. Just like ask because maybe, or maybe he has joined some other place. Because that meeting does not have the link to join.
Yeah. Okay. Let's see. I will keep an eye. If someone joins, and you guys, if you have permissions, as someone join, just add him. So yes, so this is one choice they do, is they choose ripple over a observable stream or event emitter, because they wanted to pose model to generate tokens when UI is not able to keep up. It's a cost saving and back pressure aware mechanism.
What is back pressure?
Back pressure means when producer is producing faster and consumer is not consuming fast enough, consumer can signal the producer, slow down,
Mm-hmm.
otherwise I will overfill. So instead of like, there are two mechanisms here. One mechanism is like you just overfill and lose the data. Second is like signal back to the producer that I am like, I can consume at this rate only. You have to slow down. That is called back pressure aware mechanisms. So back pressure is bottle pressure or like pipe pressure.
Okay, okay, okay.
In a pipe, right? Like if like you are like the consumer is slow, producer cannot go fast without like leaking or overfilling or like
Got it.
busting. So it's a back pressure aware mechanism. If UI is not able to present token fast enough, generation will pause. So model will have to stop down.
So this
Model
UI will be terminal. It might be your code editor. It can be anything, right? Whoever it.
UI is our like where we are seeing the tokens.
Got it. Got it.
Yeah. So basically like if UI is slow, the agent will automatically become slower, and it will like in the like again all these things are batch processing. Like if you know like BTC, batch, sequence, and channels. So if one like if the batch is slow, like it can fit more batches.
Okay.
Second, tool execution overlaps with the model streaming. So model streaming means when model is outputting the stream of answer, tool execution can overlap with it. The streaming tool executor doesn't wait for model to finish before starting concurrency safe tool. A read call can complete and return the results while the model is still generating the rest of the response. This is called speculative execution. If the model's final output invalidates the tool call, rare but possible, the result is discarded.
Mm-hmm.
So basically, like agent is like tools is working independently. Model can also say, okay, this was the wrong tool call. In that case, whatever it was, we add it to the context, we just remove it or invalidate it or discard it. You understand? But that's very clear. Most of the time, tool call is correct, and we're doing the right thing. It's speculative. That speculative means like you are making a speculation that it will be correct. It's a heuristic. Third thing, the entire loop is re-entrant. Basically, we can re-enter the loop. When the model makes a tool call, the results are appended to the message history, and the loop calls the model again with the updated context.
Okay.
Right? There is no separate tool result handling phase. It is all in one loop. The
Mm-hmm.
model decides when it is done by simply not making any more tool calls.
Mm-hmm.
Okay. Then it's their permission system. So there are multiple permission system. First is like they have some internal system called bypass permissions, in which there are no permissions. It's for testing and internal use. Right? Then we have default. Default permissions means it's the default permission that like we ship when we ship the product. Right? So in this default, user should approve each action. Then you can say, don't ask me. So everything is allowed. Right? Right? So in don't ask, everything is still logged, but there is no user prompt. Like user prompt is like not the user prompt. It means like user will not be prompted back to say, can I do it? Can I do it? It will not be prompting back. You know? So like it's not like user prompt, like there is no prompting back to the user.
Yeah, they are the permissions boundaries. Yeah, I know. Correct.
Yes, and then auto. So in auto, they have a something called classifier trans LLM, a very lightweight LLM that would basically decide automatically whether whether this tool call is risky or safe. If it is safe, it will do it.
Task
The
or
second
like
model running, it's a LLM, so it's intelligent, but it's very lightweight. It just sees based on the context, is the tool call correct?
it
If
you have
call
to
is
delete database or like simple thing, then like it can take on decisions basically based on the risk or not.
yes, and then the bubble mode. So bubble mode is applicable for the sub agents. When an agent spun up sub agents like this, like sub process type of thing, right?
Hmm.
So the sub agents, it bubble means whatever the permission agent has, sub agent will have the same permissions. So
Okay.
when agent is calling sub agent, it has option. By default, it will call with bubble. Bubble means whatever permission I have, my sub agent will have the same permission. But it can also call sub agent with lower permissions.
Okay.
Yeah. So you can call your sub agent with lower permission, or you can keep the same permission level as you have.
That
If you
bubble,
bubble means
that is
same thing.
bubble.
You're bubbling. So bubbling means like same information, same permission set. Whatever you have, it
Okay,
will
okay.
bubble down to your child or sub agent.
Got it, got it.
So permission resolution. So let's say tool is something called write file, and
Hmm.
permission level is default. So how does it resolve? There are few presets, but like how does a read file work in auto mode?
Mm-hmm.
I think it will be allowed, right?
Mm-hmm.
Let's try this one. Read file in auto mode, right? Then there's a matching hook, has matching hook, allow, deny, or ask. Let's remove the hook for now and resolve it. So tool call need permissions, hook rule match, tool check permissions, tool self allows, and it is finally allowed.
Mm-hmm.
Basically, if you do read file in auto mode, you will be allowed. But what can you do bash RM in plan mode? It should not be allowed because plan mode is a read only mode.
Mm-hmm.
You know plan mode, right?
Ah, correct, correct. Maximum time now I do plan
Like
only
they're
before
not
that.
allowed to do anything. The ask
Correct.
mode and plan mode are like read only modes. In ask mode,
Okay.
and they cannot modify the code base or something. So if you try to do RM in plan mode, it should not be allowed, right? So it is showing you what is the permission mode. You are doing plan mode right here.
Mm.
So let's resolve it. So tool action permission and denied, right? Finally. So tool action need permission. A tool use block is parsed from the model response, has hook matching, and hook means like you can override it here. Allow or deny. Allow, let's say. So if you
Oh,
say,
okay, okay.
yeah, so you say bash and bash command doing RM, deleting something
Mm.
in plan mode, but you say override hook allow, then it might be allowing you. Yes, because you say hook that overrides the permission model.
Mm-hmm.
Mm, Ask will, I think, the default permission model. It will ask user.
It will query get clarity. It is a kind
And
of plan only.
deny will do deny. But if you don't have any hook, even then, by default, it understands plan is a read-only mode. You should not do bash RM. Now, write with hook or write. So you want to
Mhm.
write in default mode. Can you do write in default mode?
Right in default mode. Yeah, I
I
think
don't
we
know.
can.
I don't know. But if there is a allow hook allowed, it will be
Ah,
allowed because it's overriding default behavior to allow it.
got it.
Now, next thing, MCP tool in default mode. Can we do MCP tool in default mode? What was the default mode? Standard interactive mode. User approve each action. So what will
Oh,
happen? MCP tool in allowed load. It will talk to the user. Tell me, right?
okay.
Because that is default mode is right. Standard interactive mode. User approve each action. So
Mhm.
MCP tool user has to approve. So it will go back to the ask user, right?
Okay.
Now next preset. Uh, bash in full auto don't ask. So you have permission model don't ask, means do whatever you want to do,
Mhm.
and you have bash.
Mhm.
So what do you think will happen?
It will decide. I think it may do. It may delete also then. Or there
So
is no best command it can do. Like other than RM, it will do other things. RM, it will ask and other things he can do.
yeah, I think it will allow. I think unless you are auto mode, there is no intelligence.
Okay. Okay.
So unless you are in auto mode, there is no LLM here. So when you say don't ask, it will not ask. It will do it. That's what my theory is. Let's see. Yeah, done. It will let you delete things if you put in don't ask mode. Yeah, so don't put in don't ask mode. It's risky. Now write file that says accept edits. Accept edits is a hook, right? Also the permission mode where you accept the edits automatically. You don't have to click and accept the edits, right? I always turn it on. Have you seen it?
Hmm?
Like as you modify the file, right?
Uh-huh.
Right. Whatever the file is modifying here, right? For example, this file.
Correct. Correct.
Yeah, like I do not have to click. I think these are deleted. I don't have. Hmm. I don't have to click on accept edit. It will automatically accept edit, but it says
Correct. Correct.
automatically deny. It will deny
It
because
will ask approval.
no, it will deny because there's a denied hook. So basically, like denied hook will put a denied.
Mhm.
Then it's a multi-provider architecture. So like we basically don't, when we say create Anthropic client, we don't care about where it's streaming from. It can stream from Anthropic or Bedrock or Vertex or Foundry.
Hmm.
And Anthropic SDKs are independent of it. And whatever the endpoint is, it will work still.
Mhm.
All your software stack is like independent of which endpoint you are streaming the token from. You can also load your custom endpoint to stream the tokens, and all the stack will work.
Hmm.
Okay, so this is like basic thing, and the provider selection determine the state. Build system. So how they build things, I don't know why we need to know it. Then how the pieces connect, same chart again, right? User, ripple loop, query loop, state layer, or front-end state layer, agent memory, tool system, hooks, task, same, all the same things.
Correct.
So the memory is the important part. It feeds into the query loop, right?
Mhm.
As part of the system prompt. The query loops also drive the tool execution. So in the query loop is the main part, right? That runs the tool execution right here.
Mhm.
And tool results are feed back into the query loop as messages, right?
Mhm.
Now, tasks are recursive query loops with isolated message histories. You understand what isolated message history is?
Okay.
Isolated message history was this thing. So this was the subagent, right? That was created when we saw this example, right? So this is a isolated loop where there is an isolated prompt and isolated context. Look, right? And it has bubble permission model, right? So these two loops are isolated. They have different context than the parent. Hello? Doubt?
No, no, no. I get.
Okay. Yes. Hooks intercept the query loops at a defined points. State in read and state is read and written by everything with the reactive store bridging to the UI. Okay. This circular dependency between the query loop and the tool system is systems defining characteristics. Circular dependency means tool is putting into the query memory and query memory is calling tool and tool is calling back information in the query memory. So this is the circular dependency here. Tool point to the query point to the tool, right? In a way, sub agent is also a tool, right? Or no?
Sub-agents was also.
Tools.
Correct, correct, correct.
That's why like they have the exact same architecture. I think they wanted to make it complicated. That's why they have a front end state, and they wanted to show like sub agent can like sub agent is just a tool, right?
Mm-hmm.
Yeah. Again, yeah. And then why we have to show ripple even in this architecture? Think of it like a CLI, right? Ripple is just like converting into API call. That's it. Anyway, so this is the most important part here. The circular dependency between the query loop and the tool system. So query loop is executing tools, and tools is defining the context that query loop will put into the model. Okay, the model generates the tool call, right? Model will give you tool called tokens. Then tools are executed and produce rules. Like again, uh, tools don't get executed automatically. Query loop will execute the tools with the tokens. Once it detects the tool tokens, it will call the tool system with the right tokens. Results are appended back into message history. The model sees the results and decide what to do next. The cycle continues until model stop generating tool calls or a external constraint like token budget or max number of tons or user says abort terminates it. Okay. So how does this book works? Chapter 2 traces how the system boots to the point where path can execute. Chapter 3 explains the two-tier state architecture of path, reads, and write, and chapter 4 covers the API layer. So the generator loop pattern, right? This is like in TypeScript, and like that's what they are using for the loop. The self-describing tool interface. All the tools are describe how they should be called.
Mm-hmm.
What are the arguments? What are the argument values are allowed, so that agent can use them properly. Separate infrastructure state from the reactive state. So infrastructure state is a different thing, and reactive state is a different thing, because like one is like for user tracking and second is for message tracking. One is like UI front end and second is the back end state, right? Permission models, not permission checks. We don't do permission checks. We have permission model. So like based on the context, you might or might not have a permission to do it something based on the context. Recursive agent architecture via task. So agent can call agents. That's recursive agent calling agents, and this agent calling agent is called task. And the permission escalate to upwards via bubble mode. Okay.
Okay, huh.
Then next part, I don't like understand this purpose here. It's starting fast. So this is how it executes. Like CLI is like the CLI that we interact with, that calls the main function, that calls the init function, that initialize all the things, and then we do some config or setup, and then we have the ripple finally. This is like one time when you start the claude command, first time. It's like what happens when you start cursor. Who cares? Means I don't understand why we should care about these things. But this says they try to optimize the start time by executing them together, executing some part of IO and some part compute in parallel. That's a very common technique.
Mm-hmm.
So I don't know. Like dynamic import is like a JavaScript concept, right? Why we want to why it is like how it is even related to context, cursor, or like anything. So it's like now I think just they're talking about what it is implemented in that particular code base, and they're just trying to do it. So trust boundary. What is trust boundary? So agent is like has a trust boundary, that what it can trust and what it cannot trust. So agent decides what I can do. So what part? So agent is working in an environment, right? You know what environment mean here.
Hmm.
Environment is like maybe its work environment is right now our cursor or cloud code, right? That's our environment. In that environment, agent is intelligent and it has a trust boundary that this things I can trust and this thing I cannot trust.
Trusting on tools or trusting on anything?
It's like which things it can do and which thing it cannot do, or
Okay.
which part, which instruction it should follow, which instruction it doesn't
It's
follow.
not. Okay. Okay.
Yeah, so it's like it's internal moral compass. So trust boundary is not about using user trusting cloud. It's about cloud code trusting the environment. So a malicious bash RC could send LD preload to inject code into subprocess.
Hmm.
Trust dialog ensure that user explicitly consent to operating in a directory that might have configured with someone else. So like it basically try to see it. The cloud code is defining it's an environment, but it's like defining a trust boundary for agent, what its agent trust or not trust. So again, you can do that. You can use LD preload. LD preload is a library loading command, right?
Hmm.
Node option is a command. How do you modify Node.js, right? Again, they are using TypeScript, and TypeScript is running on Node.js, right? Compiling to JavaScript, and JavaScript is running on Node.js, right? Right.
Okay. 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 Correct. Correct.
And then path variable, you can add more
Correct.
binary to the path and other things. All these things, can you do it? So these can be dangerous. Is
Hmm.
model trust the environment to modify these things? So that's what the trust boundary is. So
Okay.
before before trust, TLS socket pre-connect environment variable loading, right? And yeah, it can basically here it's like before the trust boundary, it's basically doing everything, right?
Hmm.
And after trust boundary, it like it do something else. So this is like initialization time. And yeah, when you initialize, trust boundary is not there, but after you initialize, and it is like after you start a trust boundary, so that like you have to do things, you can do different things that is that doesn't bypass the trust model.
Hmm.
Then pre-action hook, we already discussed the hooks. Pre-action hook is so every command that we give, it's handled by something called commander.
ठीक है.
Git clone, git clone is a command, right?
ठीक.
So that
हाँ.
is handled by a commander that will run it. And then it will also check for flag if git clone maybe dash dash something, right? And subcommands and position arguments, it will check tech. So command is like Linux command, right? Or bash command. So this information is like pre-action hook is executed before running a command. So whenever you do a command, like maybe ls is a command, right? Before doing that ls output, it will call pre-action hook, right? Why do you think we need that?
Pre-hook.
Yeah, pre-action hook.
अच्छा हाँ, like before it
Any
is a
command.
security test validations, like whether it is like we do in the git commit also, no? Before git commit, if I have any conversion like format the code or anything, so that does everything. Even before you commit, it will do all the things. If anything, it will in advance only it will give the error. Like pre-hooks are basically doing something before validation. It is they are used for doing
Yeah, yeah,
validation.
but action is command, right? If you do
Oh.
git clone or ls command or top, right? You see what are the process. Before running top command, it will run this pre-action hook. Yeah, it can be useful. I'm just thinking why what can be used, what they will be using it for.
Hmm.
And then it says like this is the process, right? Command handling. Command when you put some commands, right? And then agent loads. Then hook loads. then plugin loads and MCP loads. This is the startup phase, right? So this command loading is the startup command loading here. So they want to say this is like a 25 millisecond operation if you do sequentially, but you can parallelize them. And then if you see, this is the time sequentially like 800, but you can parallelize the git status and cloud some things IO, right? And you can done with 80 milliseconds instead of going with 130 millisecond if you see like startup time. Again, it's like it's generally, this is very general information how to optimize the app startup time. Nothing to do with cloud here,
Hmm.
right? So means right again that you basically want to parallelize IO. Means disk read. Disk can read at a particular time, right? Like disk has a buffer or like read write buffer or like there's a disk speed, right? If you want to do all the disk heavy operation together, this will be bottleneck. But if you want to like do compute heavy and disk heavy in parallel, so like for example, this thing is compute heavy, but this might be doing this disk heavy operation before first API call. You do TLS and pre-connect before you do network part or disk part first, and then you do the compute. Similarly, this Claude MD read should be done before maybe setup an init. Right? It can be done before init. And this thing also, git status command is done before this thing. So it's rightly aligning so that the startup time can decrease. I am not finding it interesting. Can we skip?
Yeah, we can. So actually now, like I think
Basics
we,
are that only, yeah.
we can do next iteration because it will be too much for now. So we can
Yes.
do it next time.
Yeah. Okay. Yeah, I think it's good for today. Any
Uh,
questions so far?
I think I got a lot of internals. Yeah.
Yeah.
Anyone?
Shanky?
No, I'm good. Yeah, thank you. I learned a lot as well.
Okay.
Yeah.
Sure. I think we have a recording session. I think you
Yeah.
don't, if you want to like see the few minutes before we started late as well. So I don't know like if you missed
No.
much or
So
nothing at all.
I will share that, download the recording and share in the group. Like and next session we can have maybe on Sunday. Next to next Sunday. This Sunday I am not available. Like
Okay.
May 4th or something. 3 or
Yeah. Sound good.
okay.
Oh, okay. Thank you.
Okay,
Bye.
thank you.
Bye.